All right, ladies and gentlemen, in this video we are opening up a discussion of perimeter and area in the coordinate plane. Perimeter and area hopefully are not new terms for us, but we are going to think about how we can specifically utilize things like the midpoint and distance formula to make a context to perimeter and area in coordinate geometry. So let's start some things on off with. And if you don't have a piece of graph paper, just kind of sketch one out there on your paper. We have our x and y axis here. We want to draw a quadrilateral, which we're at 1, 4 for A. So 1, 2, 3, 4 right there. So there's point A at 1, 4, and we're going to be at point B at -3, +1 for B, -3, +1. C is going to be at 0, -3. So there's point C at 0, -3. And D is going to be at 4, 0 right there. So at 4, 0 for point D. That's what we're starting some things on off with. So the next task says, are the adjacent sides of the quadrilateral ABCD perpendicular to each other, and how can you tell? Well, remember correctly, what defines two sides in a coordinate plane to be perpendicular or parallel? Well, remember, in a coordinate plane, what determines parallelism or perpendicularism is the slopes of the lines. And so what we needed to find out is we need to identify what the slopes are of these particular ones. And so we want to know the adjacent sides. So adjacent just simply means sides next to it. We want to know if AB is perpendicular to AD and if BC is perpendicular to CD. So the slope, remember guys, is the change in y. So slope will equal y2 minus y1 over x2 minus x1. That's also thought of as the change in y over the change in x. That triangle is a Greek symbol for delta, and delta just means the change in. So I want to find the slope of each of these. So I want to find the slope of AB. So if I find the slope of AB, so slope of AB, that is the change in y, so 4 minus 1, 4 minus 1 over 1 minus a -3, so 1 plus 3. So I get 4 minus 1, which is 3 over 4. So the question is what is the slope of AD going to be if these are going to be perpendicular? Well, remember, perpendicular lines have opposite reciprocal slopes. You flipped the fraction, and if it was positive, it became negative. If it was negative, it became positive. So this is going to have opposite reciprocal slopes with AD if it becomes -4 over 3. So change in y is 0 minus 4 over our change in x, which is 4 minus 1, and we get -4 over 3. So these are perpendicular. So I can say that AB is perpendicular to AD. And that upside down T is our symbol for perpendicular segments. Well, I can do the same thing with BC and CD. Same thing with BC and CD. So the slope, let me change colors just so we don't get confused of which ones we're talking about. So the slope of BC, so again, change in y over the change in x, so -3 minus 1 over 0 minus -3, -3 minus 1 over 0 minus a -3, so it's a +3. So we get -4 over +3. And then the slope of, what was our last one? CD. Yep, slope of CD. Change in y is 0 and ends up being 0 plus 3, and 4 minus 0. So we get 0 plus 3 and 4 minus 0 for a positive 3 over 4. Again, opposite reciprocals. We switched the fractions and we ended up getting a different value in terms of positive and negative. So I could say that BC is perpendicular to CD. All right. So how is this going to benefit us in terms of thinking about our perimeter and our area of the graph? So let's think about this here for a second. What's the perimeter? What does perimeter mean? Perimeter means distance around the quadrilateral. So what do we need to do to find the perimeter? Well, we need to find the distance around. Well, how do we find distance? Distance formula. So let's think about all of our segments that we're dealing with here. So we've got our segments of AB, AD, CD, and BC. So we're going to have to use the distance formula to find all of our distant segments. So we've got AB. So let's go ahead and let's make a quick copy of all of this. And let's go ahead and paste it in our next segment here. There we go. Now we don't have to keep going back and forth. So I want to find the distance. Remember our distance formula. Distance is equal to the square root of x2 minus x1 squared plus y2 minus y1 squared. So the distance from A to B is equal to 1 plus 3 squared plus 4 minus 1 squared. So we end up getting 1 plus 3 is 4. 4 squared is 16. 4 minus 1 is 3. 3 squared is 9. So 16 plus 9 is 25. So I have the square root of 25, which will equal 5. So the distance from here to here is 5. What about from A to D? The distance from A to D is the square root of 4 minus 1 squared plus 0 minus 4 squared. So we have 4 minus 1 squared, 3 squared, which is 9. So we have 9. And then again, negative 4 squared is 16. So once again, we're looking at square root of 25 equals 5. And then we would do the same thing for DC, from D to C. So we would find DC. And for DC, we have 4 minus 0 squared plus 0 ends up being plus 3 squared, so 0 plus 3 squared. And once again, you see we have square root of 25. And for the last one that we would have is BC, and I'm just going to go ahead and tell you guys, it's going to end up being 5 as well. And so, yes, it does end up being a square since all sides are congruent with a length of 5. So if you want to find the area of this, don't forget area for a square is side squared. So our area would be, let me change colors, would end up being, of course, 25. And there was our answer, yes, to is it a square? And then last but not least, let's think about this in context as of kind of right now. If we took it just a little bit farther, we've connected some different points, I guess, if you will, right? So we've connected some different points here. And I want to kind of think of how many now polygons are formed if we've now kind of changed up the scenario. Well, how many total polygons? Where a polygon is just simply a closed figure that has a side. So we'd have 1 in this triangle, 2 with this triangle, 3 with this triangle, and 4 with this one right here, 5 with my square, and then 6 with our big triangle. So we end up having 6 total. So let's find the area of each polygon. So then we kind of just had to think to ourselves, well, what am I really trying to find? Well, this is a triangle, so half the base times the height is the area of a triangle. So I get half of the base times height. Well, when it's vertical and horizontal like this is great news because we can go ahead and just simply find the lengths by just counting the number of units. So if I'm here, I've got 1, 2, 3, 4 units for the height and 1, 2, 3 units for its base. So 1/2 of 3 times 4 ends up giving us 6. And very similarly here, we have 1, 2, and 3, and then 1, 2, 3, and 4. So these are all going to be 6. This is going to be 6, and this is going to be 6 right here. Our square in here is a 1 by 1, so a 1 times 1 is going to end up just being a 1. So the question is the sum of the areas of the 5 smaller polygons equal to the original square we made? Well, 6 times 4 is 24, plus 1 is 25. So yes, of course it is. All right, so all of this to kind of introduce our topics of polygons and utilizing perimeter and area within a coordinate plane.